Hello everyone, it is 7/14/2020 and it's another Level Design Live lecture. In this live lecture we're going to be covering the course content of week 2. So I've got episode pulled up. Let's hop into week 2 and walk through this. So it's time for your first major milestone activity, which is the prototype. The prototype is going to be us getting the basics of your level mechanics, of your placeholder objects put together, so that when we get to actually constructing your level, you have all of the necessary required pieces that go together to make this whole thing work. There's a quiz this week. The quiz is based on all of the previous material, as well as, so like we did like a version control quiz. So there's going to be some version control questions. There's going to be some questions about the project, about any of the things from week 1. So you can always go back to previous information to pull that up. But it's, your first graded quiz. And then the week 2 QA, which we can, definitely go into. Let's actually do that one first and get that out of the way. So, just like week 1, week 2 is open for the entirety of week 2. That doesn't mean that you should wait until that date that's on the right. July 20th, bad time to start working on your stuff. July 13th, yesterday, definitely good time to start working on your stuff. So the earlier you get into the work, the earlier you get into seeing what's required of you, the easier time you're going to have setting up the schedule of what you need to do when this week. So for week 2 QA, you all have done project setup, and project setup was getting your working project and a compiled build up on Perforce. So whether or not you were able to get it up, whether or not you were able to do part of that and not all of it, you have some version of something up on Perforce ready to go. So the idea of the week 2 QA activity is that you're required to make a post that has the location of your compiled build up on Perforce, so that someone can go to your post and then test your build to make sure it works, and then give you a reply to that post. So the way that this works, part 1, as I said, you're going to make a post. That post is going to follow the format that you see here. So it says note, copy and paste. It might give you formatting issues, but this is the format of your post. So you're going to say that you've submitted a build to Perforce that you can, you're looking for QA testing for. You're going to insert the submissions file location on the depot. So remember that if you notice your file's location starts with like C:\/ your Windows username in some sort of folder, that's the workspace side. You want to switch over to the depot, and then you should see like 2 / depot, and then the directory on the server. And so you're using the server location or the depot location as the location of your build. And so by build, I mean under the compiled folder, you have your personal build folder that has your last name, first name. That's, the location of the build that needs to be tested. You're going to write something in change list description for the last submission you've done to Perforce. So I've got Perforce open right now. Change lists, for example, if I pop over to, let's do like compiled build in here. So Thomas's build, the change list description is what you write on it when you submit it. You do not have to make a new QA build submission for this specifically, unless you would like to submit a new build for testing. We're just looking for whatever the location on the depot. We're looking for the name of the change list that was submitted that you want to be tested. And then you can actually describe out the whatever the request is that you want tested. So here's the weird thing. We just did project setup, and by doing project setup, your build is just the default, compiled build that comes out of the project. So if you just have project setup up there and someone goes to test your build, the response is probably going to be, this looks like project setup. There's nothing for me to test. And that's actually a good piece of feedback for you, because over the duration of this week, you should be submitting updates to your working project folder and to your compiled build folder. So compiled builds are not like, you don't check out the compiled build. You remove the previous build and then you add a new one, and then your working folder, you're going to follow. There's a video I sent out last week that talked about like Perforce workflow. So when you want to edit a file, you check it out. When you want to add a new file to the depot, you mark it for add. If you want to remove a file from the depot, you mark it for delete. And then when you submit a change list, that change list runs through on the depot, and it makes sure all those actions take place, and it updates the history of those files. So all the work that you have submitted then happens on the depot, and everyone else can see it. So if you're going through the week and you have not submitted a compiled build for, let's say you start working on prototype and you've gotten, the first level mechanic working, if you don't submit that, then the feedback you're going to get back is, this is just project setup. And, once again, good information for you. That means you should probably get a new build up. So if you've already made a post, like if you make a post today and it says, this is the build that I have ready for QA feedback, you can actually go back and edit your post once you get a new build up. So as soon as you get a new build for prototype submitted, you can go back and edit it, change the name of the change list description to like, first pass prototype or whatever it is that you submit to Perforce for that, build submission. And then in the actual request details, you can then say, level mechanic 1, test to see if it's functional. Tell me if there's any bugs or whatever. And then, all the other students in the class are going to go look at your post, and they're going to do replies to it. So there's a requirement for a certain number of replies or bug reports that everyone's going to do. So you find a post, you go download the build, you play through it, and then you reply to that post. That way everyone's feedback is attached to their original post, and you can go back to there over the week and see everyone's different reactions to the build that you have submitted or not submitted, right? As a side note, if you're going through the week and you notice that nobody's putting up a post, that everyone has completely ignored this activity, it does happen. That's why I always suggest that you start this week, early, like yesterday or today, get a post up so that there's something for someone to respond to. But if you get to the point where nobody's submitting a post, everyone's willing to take the professionalism deduction and they don't want to do a discussion, I understand. But for those of you that actually want to do this, you can go to whatever posts are available on the discussion, and just give another reply for feedback so that you get the points for it. If nobody else does it but you, then play your own build and reply to it, and just, give yourself pointers or come up with whatever your next tasks are for it. As long as you're interacting with the discussion and you're not just skipping past it, then you're not going to lose professionalism for it. But the goal is that everyone makes a post that has a build that can be tested, and then you reply to their post and give them feedback. So remember, the key thing for that is put up a post, today, and then later down the line, when you get a new build up on Perforce, go edit your post and rename the change list to the one that you've just submitted, so that you're getting more up-to-date feedback from those that are participating in this discussion. But that's kind of how that thing works. And so by the end of the week, you should have one post that said that you had a build that needed feedback, and then you should have replied to other posts up to 6 different times, giving people, feedback and a playthrough. That's, the gist of this activity. So both of them have a little format that you can follow. Just fill out the post, fill out the reply, and you should be good to go. So that is the week 2 QA, and this QA activity will actually happen for the next 2 weeks as well. Week 4 is a little different, but the general idea of these things is, if you have a build up there, make a post, and then test other people's work and give them replies. All right. So I talked about the week 2 QA, the quiz. Um, it's open all week. That's plenty of time to do a very short, 26 question quiz. If you forget to take the quiz and we get to the end of the week and then it closes, if you ask me to reopen the quiz, no, it's been open all week. You have plenty of time to do it. Just get in there and knock it out. It's 15%, so it's got a hefty weight on it. Get in there and take it. And then get back to actually working on the fun thing, which is prototype, or hopefully it's fun. It depends on how much you like building things and animating things and making them work. So I want to take the rest of this to actually talk about prototype specifically. Load this up and take a sip of water. Alrighty. All right, just like other activities, when I mentioned in the previous, last week's lecture, remember that there is an embedded document. So if you don't want to scroll like this, you can pop this open and see it. However, there are 2 documents attached to this activity. This one seems to always get skipped. Not always, generalizing always. A majority of students skip this one because they complete the top and then close this activity. Please do not skip submission requirements. It's how you turn in your work. So I'm going to open both of them. And then at the very bottom, it talks about just the general professionalism deduction. If you ever wonder how many points of professionalism are deducted from different activities or steps or whatever, you can always go to the bottom of the activity and find that, or the bottom of the submission requirements document, depending on which one we're looking at. Anywho, so the instructions are on top, submission requirements on the bottom when you're all done. Let's get into the instructions and make this bigger. So welcome to your first milestone for the individual level project, the prototype. For this milestone in particular, we're going to be working inside of a scene called Scrap's Toy Box. So a toy box is a test area or a debug area where a designer can put together various gameplay setups to see if something is fun or not, without having to deal with loading a bulk of the game's assets and features. So this is sometimes referred to as a metrics level when you get all the way to the other side, like we're in midterm project right now. When you get all the way to capstone or your final project, they call it a metrics level instead. So I want to make sure I cover that. So as an example, Mario Sunshine, you can see we've got grids and colors and objects, and not a level that you might be familiar with if you've played the game before. These are the test areas or the toy boxes where you actually get Mario doing what you need them, how you want Mario to work, how objects work, and it's all about getting all your functionality working in a test environment. So this is not your level that we're working on yet. We can't build a level until we have the objects to build your level. You should never go into building a level and while you're working, hunt for the stuff that you want to build that level with. Get all that pre-production stuff done early so that you have everything you need to build this space out. And then if things change as you go, you can always add things, remove things, whatever. But don't build things on the fly. Always have a plan. Always have steps in your production pipeline that you're going to go through. So this milestone's not your level. If anybody's building their level right now, you're not working on the right milestone. So this is a testing environment for various elements that you will use to create your level. If you have issues getting through something working in this milestone, then you might want to redesign something. You might want to change your level map. You might want to cut content that's unfeasible, whether or not it's something that you just can't get scripted and working, or if you struggle with animation, or if the physics objects are giving you trouble for some reason, then you have to make that decision as the designer. You have to be comfortable with cutting things that you planned, even though you might be stuck on that idea. We have to be able to drop those ideas and come up with something on the fly and get things working at that point. Not I used the wrong word at that point, but in the pipeline, if something's not working, we can't just stop and try to struggle to get that thing working, because it's going to drag all the way to the finish line and then nothing's going to get done. So being smart about it, removing things that aren't going to work, and then coming up with a replacement is a good skill to learn. And so you're going to be dealing with that in this milestone. So, if you have anything that doesn't work, cut it and replace it with something simple that still meets the requirements and the grading criteria for this activity. One of the biggest things that you can lose points on in this is just not being aware of what you're being graded on. So we're going to cover that as well. Make sure you hit all the points in that rubric. It's set up so that anyone's level can fit in it, but it's all based on you understanding the definitions when we talk about a level mechanic, and then adding the various pieces and parts to that help build your version of this. So in this milestone, we're constructing 2 test areas. One test area for each level mechanic. Now, I don't know why I need to say this, but this image is not what you're building. It's just an example of 2 rooms. So if you submit a room that's built out of one wall and a room that's built out of another wall, and there's nothing in those 2 rooms, and that's what you submit to me, you're not going to get a good grade. So this is an example image. This image just shows you 2 different spaces. One is going to be for your first level mechanic, and one is going to be for your second one. You're going to build this out of modular placeholders that we will construct using reference images from our selected level theme. So in level proposal and in project and portfolio 2, you were tasked with coming up with this design, and this design has a theme that goes with it. Your level exists somewhere. So whatever reference images you used to put that together, go ahead and grab more if you don't have enough. Get as many things to look at as possible. But get reference images of things like walls, floors, ceilings, props, lights, stairs, whatever, so that you have all these different things that you can pull from when you're required to construct some placeholder objects. For example, I've got a student's project up here that was, kind of way beyond what I normally see. So there's objects for an office building. We've got a chair, a table, lights of 3 different types are seen in this one shot, doors, windows, etc. I noticed that they're all in this kind of gridded out, non-final material version of things. And that is because we're working with blockouts. So your test areas can resemble potential rooms from your level, but it's not required to be an actual room from your level. It's just a test area for your level mechanic. So you're going to be constructing these test areas with modular objects that you're going to build in here, which we will get into in more detail. But it does not have to be one of your rooms from your level. We will not be using final assets in this course at all. Instead, our objects will exist as a block mesh or blockout or gray box or however you want to describe it. So we can rapidly iterate on what's important at this stage, which is functionality and scale and placement, but not how it looks visually. So as an example, I've got the Rabbids Mario game from Ubisoft on the right, final assets, and on the left, looks very similar. It's, a bunch of blocks and grids and placement of things in the level. So if you ever wanted to look at what, blocks look like or blockouts look like, you can jump into the Blocktober hashtag on Twitter and see a bunch of AAA studios and indie projects and things like that sharing their various forms of blockouts. So each test area for this milestone should contain 1 level mechanic. And remember, a level mechanic, when we're verifying what that is or we're describing what that is, the player uses a core action. It is verified in some way, via an object or a script or something, and then there's a success event. Something positive happens that is a level progression event. It lets you move forward in some way. So something as simple as the player pressing E at a lever causes a gate to open and allows the player to go through that gate to the next area. That's a level mechanic. That's one thing that works. These level mechanics should be fully functional in these test areas, and also give the player feedback when they are completed. The previous lecture I did visual effects, I did messages, and I did sound. So you can look back at that to see how to make sure that you have the various levels of player feedback attached to your level mechanic. So you're going to be graded on the following in this milestone: your ability to utilize version control, that's per course, and that's for your submission. So remember, not just a submission at the end of the week when it's time to turn in, but you should submit over the course of, over the length of the week. So maybe in 2 days you submit your first pass build and you update your working folder, and then in another day you do another one. Whatever works for you, as long as there's more than just the final submission at the end of the week. The layout of your setups, the communication of the gameplay elements involved, and the variety of those setups. So if you have 2 test areas, and in one room you have a lever that opens a door, and in the other room you have a pressure plate that opens a door, they both have the same result. And so that's not variety. You should be doing something different with both of them, so that when the player sees these objects, this gameplay setup, they know that, oh, it's a lever and there's a door. I have to pull the lever to open the door. Or there's a pressure plate. I have to use the pressure plate to lift the gate so that I can go under the gate. And as long as you come up with a plan for your 2 level mechanics and you're consistent with how they're set up in your level, then the communication is going to be much easier to get across to the player than if you change things randomly to make them more interesting or fun or unique or whatever, because being consistent with feedback will allow the player to learn what you're trying to tell them. So verification of the gameplay interactions, they should work through the success events with visual and audio feedback. So whenever we're doing feedback, try to do at least 3 forms. 3 is always the magic number. So something visual, a simple particle effect, something audio, make a sound that is relative to whatever your level mechanic is. The interactive objects that come with the project, which we will talk about, they do make a sound, but you don't get credit for the sounds that I've created. If you put the lever in and it makes a sound and you go, it makes a sound, great. No, your success event should make a sound. So make sure you add your own sound, your own visual feedback to your success event. That's, required. Also make sure the game runs at a playable quality and frame rate. This may seem unknown at this point because you're not sure when it's going to be under frame rate or not. I will tell you exactly how this project becomes, slow and hard to work with at this milestone, which is when you're using Pro Builder and you see that there's a sphere in the Pro Builder objects menu, and then you add it and you notice it's not round, and then you increase the subdivisions until it's as smooth can be. That's when the project slows down, because you've added thousands upon thousands of polygons to your scene, such as you made a perfectly round door handle. And so you make one knob that's perfectly round, and then you put it as part of a prefab for a door, and then you have like 4 of these doors and one knob on both sides of the door. You can see how this continues to get worse and worse. So when you're building objects, we're doing general silhouette. Don't worry about making it pretty. So if your doorknob is a square, a cube, just like something simple, just build to the silhouette. Don't build to make it pretty. Avoid over smoothing things. It's going to cause you problems. Construction of decorative props is required for this, light sources, and breakups for your modular test areas, and we can get into that as we go lower. I just want to make sure I cover all the grading stuff in detail. And then the overall presentation of the 2 test areas, the level mechanics and the constructed placeholders required, with required materials. So we have to, there's a specific set of materials that we're going to be applying to these level objects. More on that later, but this is what we're being graded on. So I'm going to show you what the rubric looks like. rubric for the prototype is right here. It says, please review the rubric so there are no surprises. Let's review the rubric, shall we? So I'm not going to go too far into this. I just want to show you what our rubrics look like. There's one on this and one on the actual level activity, which is first playable. They look very similar. So if I zoom in on here, at the very top, we have the different grade ranges. So superior, satisfactory, and unacceptable with the various, separation of points. And then on the left side, categories, all the things we just talked about. So version control, layout, verification, props, and presentation, all from that little description that I just gave. So in these categories, your goal is to shoot for everything in superior. But if you hit things in the previous category, so if you did everything in superior, but under version control, history only shows one change list containing edits submitted to the assets folder during the sprint. Sprint means this week. Then you would get a satisfactory on version control. That's how this works. If you hit anything in unacceptable, the grade goes all the way down to unacceptable. So your goal is to do everything in superior and to avoid the different versions of this in the other two categories. So you can always double check your work against this to make sure you're not doing what's in the previous sections, and shoot for superior at the front. At the very bottom here, we've got penalties and showstoppers. I covered this in the overview for week 1, but this is specifically for this activity. So I want to describe how you could get one of these. And then you'll know you're either, while you're working your project, you could get a big deduction for something, or you're going to have to resubmit if you get a showstopper. So I just want to make sure we cover those things. Penalties. So it's minus 20 points if your content violates the bounds of the creative vision. So if you are working on things that go against the creative vision, and the creative vision is covered in the Scraps game design document, it was linked in Welcome to Level Design. So if you are not familiar with the creative vision, if you're building things that go, against there's a page that specifically says against the creative vision. So if you're doing things that are against the creative vision, you will lose 20 points off the top of your project. If the submitted build includes assets outside of the required placeholder content, you are not to import any assets that you did not create to this project. So if you created an entryway that is it's the door or something that you wanted as a success event for your level mechanic, you are totally okay to import that. However, you cannot import any final textures or materials, so you're going to have to change the materials on your entryway from Project and Portfolio 2 to make it fit the requirements of this class. We are not teaching you how to edit sound effects or how to create. I show you a little bit of creation of particle systems, but I'm not grading you on the creation of particle systems. I'm not grading you on the creation of sound effects. However, we require that you have visual and audio feedback. So if you import sounds or particle systems, you're totally fine. That's not a problem. But if you are importing like modular asset packs, you found a tree you really like, you're going to lose 20 points off the top. If the submitted build resembles work from a previous submission and lacks significant improvement. So if you've taken this class before and you haven't done anything this week and you decide just to resubmit your work from last time without any changes, you're going to lose 20 points off the top. This would normally fall under what other classes would consider academic dishonesty. But our goal here is to try to get you to keep working on the same thing instead of telling you no. So you're allowed to bring in your old work. You're allowed to reuse it. Just don't submit it as is. Keep working on it. Update it. Fix things. There was obviously something wrong if you're doing it again. So showstoppers. Showstoppers, remember, if you get a showstopper, you immediately need to fix the problem and resubmit. The late penalties are still counting down if you have one. So the goal would be for you to test your work before and after you submit, which when we get to the submission requirements document, I'll show you how to do that. Test your work before and after you submit to make sure that you are not getting a showstopper right off the bat. and this is how you verify that you're going to get one. If you have additions or modifications to the core game, so you've modified the player in some way, you changed the interface or added a new interface element, if anything changing what the game is at its core is present, you're going to get a 0 and you're going to be required to remove those things. So we're all working on the same game project. Everyone has to use the same template. You're just building, a prototype area that's going to test this character, this user interface, this game, and you're just building something for them to interact with. So if you're changing the core gameplay, then that's a 0 and you're going to have to remove it. If the submitted build does not use the required project template version, this used to be relevant when we updated the project consistently every so many months. It's been the same version for a long time, so you should be on 5, I think it's 5.3.0 or something of the project. Everyone should be fine with that. I don't think we've changed it for like a year now, so it should be okay. The submitted build will not run on Windows. If you only submit the data folder, if you forget everything but the executable file of a compiled build, if at any point we run the executable and it kicks an error out, your build can't be played, so we can't grade it. So make sure that you test your build before you submit and after you submit to make sure that it actually runs when the instructors go to test it. I have the same access level as everyone else, so it's not like I'm getting a different version of your project. I see exactly the same thing you would see if you re-download your work after you submit. The submitted build does not load the scraps toy box scene. So in this project, we're going to be removing the outpost scene from your build settings and adding your toy box scene instead. Toy box scene is going to contain your level mechanics, your test areas, and things like that. So that's what we want to test. If I load your build and it loads the outpost instead, you're going to get a 0 because I'm not testing the outpost scene. I'm looking for your toy box. So we have to make sure that we change the build settings to load the proper scenes. More of that is in the submission requirements document. The submitted build is unplayable with the lowest quality setting. Once again, talking about smooth doorknobs or just subdividing a bunch of stuff. If your build is just chugging along and it doesn't work on the laptops that you were provided from the school, those settings specifically, if it's chugging on those computers, then we're not going to play it. And by chugging, I mean, like characters here, like really bad chugging. If it just hitches a little bit, there's penalties in other sections of the rubric. So if the working project backup is missing from the depot, every new month I get more people that are either happy with learning Perforce or really hate that program. And I understand it's hard to get into and to pick up and run, especially in a project setting like this, but you're required to learn it. And so by avoiding submitting your work to the depot, we're not going to test your compiled build. So if you do not update your working project folder when you go to submit a compiled build, if we do not see updates on both, then you're not backing up your project. And in order for us to check your work, to make sure that you're actually doing the things that are inside of the compiled build, we need your working projects to be uploaded to the Perforce depot. So make sure that your backup is being updated on the depot and that you're getting compiled builds submitted as well. And then you won't get hit with that showstopper. And that's all of them. One of the most common reasons why the build will not run on Windows, something becomes unplayable with the lowest quality setting, is because your build settings are not set up properly. So if you go to the build settings and you have the outpost scene loaded, and then right underneath it you put the toy box scene, you're going to see a very common error where it starts spawning an infinite number of player characters. And that's because the toy box and the outpost are the same scene, just with less assets in it. And one of the systems in that scene is to load the next scene additively, because when you get to Project and Portfolio 3, you're going to have teammates with other level scenes, and you're going to load them all at the same time. So that the outpost scene and the toy box do that automatically. But if you have the outpost load the toy box, it's then going to load the toy box, load the toy box, load the toy box, load the toy box, and you're going to get infinite number of player characters spawning in your project. So do not skip the submission requirements document. That is how you make sure you submit it properly. So let's go ahead and move away from this rubric and get back to the instruction. Now that we're done talking about grading. So instructions. At the very beginning of this activity, you're going to be making a duplicate copy of the original toy box scene and then naming it with your own initials. This way you have your own copy of this scene, because when you join a team, if you are using the same scene as another student from the same template, Unity doesn't know the difference. So let's say you have a toy box scene that you've altered and someone else also used that toy box scene and altered it in their own project, and then you import them together, they're going to overwrite each other. They're the same scene. So we're going to make a duplicate of this toy box scene and then do our work inside of the duplicate instead. So make sure that you rename it with your own initials, and that's after you duplicate it. So remember, select the scene in the project, Control D. So Control D to duplicate. That'll create a copy of the toy box, and then you can move it to your own folder. So place the scene in your own folder inside of the working project. If you do not have this, make sure you've created this folder. But inside of the folder hierarchy, there are all the default scrap scenes. You should also create your own folder outside of those folders. So it says if you need space to work, create your own folder inside of the root of the assets folder. Put all of your work in your folder. That way everything is nice and neat and tidy inside of your own folder, so that when you go to export it at the end of the month, you can just right click on that folder and export it instead of having to go dig out and find all of your stuff. So once you've created the new scene, you're going to have to add it to the Perforce depot. So make sure you go to Perforce, to the workspace, mark it for add, and then submit it. While you're working, do not reposition the player. The player is underneath a game object called do not edit. It's named that for a reason. The way that certain things are developed in the project are meant to cause an issue if someone starts modifying stuff. The player gets really finicky if you start rotating and moving it from its original position. So instead of moving the player, as it says, if you need more room, you should edit the floor to give yourself more space to work. So you can select the floor that's on the ground and then just duplicate it. Control D, make another copy of it, and then move it until it's at the other end of it, so you have more space to actually do something. So modular placeholders. And this should not scare you. These images are to show you what that looks like. I'm not requiring you to build a ton of assets or whatever. So you're going to use reference images to construct reusable modular placeholder content for your level. This includes props. So that is just a good example. If you've ever wondered how buildings get put together in levels and whatnot, if you never go inside of a building, you would just have one asset that is the building. But if you're going to go inside of that building, you want to build them in modular pieces so that you can actually construct it out of these multiple objects and then go through the door and enter the building and whatnot. It makes construction of many different sizes and shapes of buildings using the same assets super quick and useful. This is the most common way you're going to see levels constructed when you get out there in the industry, is by modular objects. So if you're not sure what modular design is, I have a link to a Gama Sutra article. I'm not going to go through it too much, but there's one thing I want to point out in here. But this Gama Sutra article walks through the idea of creating modular game art, for fast level design. And so in here, if you scroll down, it says working with grids. So in Unity, our grid size is 1 meter. And so that's one grid on the Unity grid. When you use the materials in the project, one grid space is one Unity grid space. It's already mapped to the same grid size, so that when you're building, you can use that as a method of measurement. So down here, we'll see like they're aligning objects with the grid. These wall segments, so like build one wall, if you look at the grid, you'll notice it's 2 grid units, and then I believe it's 2 grid units up. It's, you know, a square wall piece, but it's 2 across and 2 up, and then a little bit of depth. You want to think about your objects in grid measurements like that. So I commonly in Unity will make like walls that are 4 Unity units long and 4 tall, and then build smaller pieces if I need like curved corners or like, you know, hard angled corners and things like that. But it all depends on, you know, the structure you're trying to create, what your reference images look like, and that sort of thing. And then measurements in power of 2. So power of 2 is a common way that you'll see things done when working in games. And so like textures, for example, texture sizes will also be these same types of measurements. So if you think back to like game consoles, the SNES or the Super Nintendo, Nintendo, Genesis, these all existed back when we used to count how much memory they had. We had the 16-bit, the 32-bit, 64-bit, 128-bit, 256-bit, then 512 would be where we would be, and then 1024. These are methods of, or rather, these are numbers of data or how you would store this information. Textures should always be in powers of 2. When building things with unit scale, you could definitely use powers of 2 for your scale. It's just like a kind of a nice go-to mentally for like whatever you want to start building or storing or whatever. Okay, so pop out of there real quick. So think building with grids, think building with measurements. So make sure everything matches the player's scale. There's a player's scale object, the player size prefab that's inside of the project. It's in the Scraps Tools folder. If you click on this link right here, it'll take you back to the game design document, and it'll show you where that object, that tool, that prefab is located and what you can use it for. So here's the assets folder, Scraps Tools folder, player size object, and then you can place it in your scene and build you know, walls and shapes and objects using that as a guide. Then you're going to make sure you have reference images. So I've got some images of a sewer here. And you're going to use those reference images to build modular objects that will go together to construct this, this test area, which the objects you create, the goal is to get the objects built that would go into building your level. So if you need a wall, go look at a picture of a sewer wall and build a basic silhouette, collision size, and everything of that wall. Ceiling, floor, you know, props like chairs, tables, barrels, whatever. You're constructing just basic versions of these objects to the player's scale with the general silhouette of that object. So it says create a collection of modular placeholders tied to your theme of your level. This assignment requires you to block out your own placeholders using specific materials. Let's look at what those materials are right quick. And so in here, it's going to jump to the materials section. And so it says inside of the Scraps Tools folder, there are a collection of prototyping materials available to you. When working on placeholders and or blocking out a level, there is no need for final assets. So inside of here, we have a couple variations of different materials, and some of them have different colors. These are here just so you can very quickly make things not look all gray, but the goal still is not to worry about how something looks as a final asset, but how to very quickly mock up spaces that are playable and testable in this prototype. So the prototype alpha material, there's a couple different colors of it. These are transparent. You can make them look like glass, like a trigger volume, acid, whatever. Just, you know, a color that still has a grid on it that you can use on various transparent surfaces. The light source material is an emissive, bright white material. You can use these on the bulb of any light source. So if you make a lamp and you just have like a lamp shade, like a cylinder, tucked in, and then you put a sphere underneath it, and that sphere has the light source material. That sphere will look like it's glowing, even though there's no actual light coming out of it. And then you can just put a point light underneath it or a spotlight, and it'll look like an actual light source being cast from something. The prototype prop dynamic material is for any prop objects that is going to move or be interactable or animate or whatever. So if you have a barrel and the barrel can be lifted with the gravinal, you would put this prop dynamic material on it. It's going to make it an orange color, and that signifies that that thing can be moved around. It can be interacted with. There's another one in there specifically for collectibles. So when you add a collectible to your level, collectibles are also, there's a prefab inside of the scraps tools folder that you can use for a collectible. And when you place it into your level, you notice it'll have this gold version of that material on it. That's what that is. The prop static materials are for props that are not interactive, that are not dynamic, that sit still and don't do anything. So if something just, like if you have like a broken, I'm just going to go with table for right now. I can't think of anything. But if you have like a broken desk or table or something, but the player cannot push it around or interact with it in any way, it's just a structure of some sort of, static prop of some sort. Static material on it, and make sure it doesn't move or anything. In Unity, there is actually a way for you to set something as static, which is in the upper right-hand corner of the inspector. You can set something as static, and it'll ignore it when calculating any sort of physics or movement or anything like that. But to signify that it is a prop, but it doesn't do anything, you can use the prop static materials. Prototype structure. So structure, we wanted to separate the idea that like a stone wall can be a static prop, but if a stone wall is used in the creation of a level structure, so roof, walls, floor, etc., we wanted to separate them so that they are specifically like this is a wall and this is a desk of some sort. So that's why there's a separate material for that. And like I said, there's a couple different variations, but those are there for you to quickly give some sort of color to objects so that they stand out from each other. You are required to use these materials. The only side thing that I like to talk about is for some reason, if you have let's say if you have a red light and you wanted a red light instead of a white light, you can duplicate the light source material and then put the copy into your project folder that you created. So remember, we had the 4 scraps folders, and you created your own named folder outside of that under the root assets folder, right? You can put this duplicate of the light source in that folder and then change the duplicate to a red light instead, and then use that for your level. But don't spend too much time caring about making something look perfect. It's a trap at this point, is to get stuck caring about the look and feel and not as much about how it functions or is the silhouette or placement or anything like that. So those are the materials. And then finally, if you are uncomfortable with building objects, I have this little placeholder document that I made up just to show the basic process of creating something and why it doesn't matter if it's perfect or not. So in here it says placeholders are a way to add something workable into a game to continue development on the gameplay. They are unfinished assets that may not fit the theme, but they're used to hold the place of a future asset. The goal of ours is to make sure that they do in fact look like they fit the theme, because we're building it specifically for this level, but that's just to describe what placeholders are. This image is from Bayonetta, but Bayonetta when it was a prototype. And so the Bayonetta prototype, Bayonetta was an early version of the model that only did like basic poses. So if you did like one of the the shooting attacks, Bayonetta would be posed the way that you would see her in the final game, but it doesn't actually animate all the way through. And then Bayonetta fought karate uniformed people and other like businessmen looking people. And that was it. They were in a room with bricks and concrete. So that's what that game looked like when it was a prototype. So we're talking about building placeholders. We require you to build your own placeholders in level design for this project. So if you need something specific, build that specific thing. You may not be an artist, but you need to be comfortable with the 3D space and how to work on objects in a 3D game. So first, find a reference image of what you want to build. Here's a helicopter. Then take the player size object and place it in your level scene so that you can actually start building with the player's size in mind. Rough out a basic silhouette of the shape of your object for collision purposes. So the main parts of the body of this helicopter is, this shape here. That's the big collidable space. If I run face first into it, that's what I'm going to hit. Notice it doesn't really look like a helicopter yet. It's the generic basic shape of one. Then add any extra elements that you want to make this functional or to better read this as the placeholder you were trying to make. So now it looks a little bit more like a helicopter, even though it's square and boxy and not perfect at all. Then apply the correct materials to this object, depending on how it's being used in your level. So this is a static helicopter that doesn't move, static materials on that helicopter. If you do not need the specific collision that you have on the object when you create it, so when you create the object, it's going to be mesh colliders. You can use simpler colliders than mesh colliders, like box colliders, capsules, spheres. Those are faster than mesh colliders because they don't reference an asset. They're actually generated in code instead. So in this example, I've got a mesh collider around the bigger part of this helicopter. However, it's set as convex, which means that these little concave parts are going to be kind of wrapped around instead. So think about saran wrap, but you keep all the air inside of it. That's essentially what's happening there, is it kind of like sucks onto it, but not all the way into crevices. Then back here, we've got, even though they're, fins, they have a box collider on them, just stopping the player from generally touching the fins. There is a capsule on the cylinder for the inside of the propeller. The propeller themselves is just one long box collider. The ski things down here on the feet are box colliders. And then you've got capsules on each one of the little cylinders connecting back to the helicopter. They could have all been mesh colliders, but that's actually slower than if you remove them and replace them with simple colliders like I just discussed. So whenever you have the chance, select a collider or a set of colliders that are not mesh colliders that fit your shape as best as possible. And then if you have to use a mesh collider, if the shape that you're working with is just too complex, then you can stick with the mesh collider instead. If you ever make something interact with physics, though, make sure that you set it as convex. Otherwise, it's going to fall through the floor. All right, so then you test your placeholder by jumping on it and running into it, crouching under it, make sure that the player doesn't run straight through the object or something like that. And that's it. That's building a placeholder object. Make it a prefab and put it wherever you want. Okay, so materials, placeholders, and back. So as it says, once again, I know not everyone is an artist, but you must have an eye for 3D space. So create objects that have the general silhouette of the final asset. So here's another image of modular objects that you would use for building some sort of a warehouse. And then here's the actual requirements of what we're looking for. So to fill empty space, we'll need to block out 3 or more decorative props. So if you are doing an office, you could have a table, a desk, and a chair. There's 3 decorative props. If you build your test areas out and it doesn't quite look like the theme you were building, create another one. General silhouette. You don't have to spend too much time on it. To light the space and the decorative furnishings, we're going to need to block out some light sources. And by light source, I mean an object that then casts light, not just putting a point light or a spotlight in your scene and calling it a day, but where's the actual lamp, where's the actual bulb that is casting that light. So find references of light sources like a ceiling lamp, a chandelier, a standing lamp, and then build simple versions of those, and then make them actually cast light by adding a point light or a spotlight to it. To keep the player on the right path and within the level bounds, you will most likely have walls, but you notice that if you create a cube and then you extrude that cube forever, you get one flat surface that goes on for way too long. So we're going to do something called breakups. And breakups, the idea is creating something that you can stick into that flat surface to break it up, to end this repetitive flat nonsense, and to add something to it that kind of it breaks up the visual. It's less upsetting for your eyes to see continuous. Instead of seeing continuous flat surfaces, seeing like a pillar every so often just kind of helps ground people in reality, and is less visually upsetting to the players and whatnot. So we're going to be creating breakups to fill in those spaces and to cut up this repetitive wall stuff. So to break up those walls or structures in general, we're going to block out 3 or more breakups. And by breakups, you can do pipes or pillars or a vent or an archway, a door frame, a window frame, wall trim, anything like that that's going to run across or up and down on a wall to help break it up. To be considered a breakup in the rubric, you have to have it connected to a wall or ceiling and or attached to the floor, attached floor to ceiling. So like a pillar that goes from the floor up to the ceiling, or a wall with a pillar that's running up from floor on the wall to the ceiling. They also must be a different material than the object they're connected to. So if you have a floor and a ceiling that are using the structure materials, and then you have this breakup, you can put the static prop material on it and pick a color that's different. That way they don't blend together. They're actually visually separate pieces. That way we can actually give you a grade for how many you have. Run into your objects when you test them. Make sure there's collision on it. If the player walks right through them, fix it. Also, right here is a great example of doing a breakup, doing wall trim at the bottom. Create custom collision using other objects if necessary. If you have stairs, for example, and the player doesn't immediately run up them, chances are, and this is very common in games, there's no stairs collision. It's a ramp. You just see steps, and the player may have a cool locomotion system where the feet actually look like they step on things. But for collision purposes, it's a ramp. So you can always remove the collider on the stairs and create a custom ramp shape that fills out where those stairs are, and then just make it invisible. Now you have custom collision for that stairway. Props are very important when blocking out content. If you have a big empty room with nothing in it, and the door is at the opposite side of the room, the player is going to run from the start to the door at the end. However, if you put objects in the way, they're going to have to walk around those objects, and so it changes the flow of the level. I like to use this image not because it's final assets, because we can't use those, but this image is here as a good example of what is worthwhile as a prop at this point and what is a little less important. And this is all about prioritizing specific objects for your level to get the most out of them. So I like to look at this and go, what in here can be used as a surface as well as what its normal intention is. For example, a pallet can be stacked on top of each other and create various stacks of objects that act as a level surface. So the player can jump on a stack of 3 and jump up to a stack of 6 and then jump up to a stack of 8 or whatever, and you've created essentially a staircase out of pallets. These big tires would also work real well in a junkyard. If you had these monster tires and you did like a couple of them in a staircase fashion, it wouldn't look out of the ordinary. The player would just jump up it and continue up. But if you had a pile of barrels for some reason and you were trying to use them as a staircase, it would look really odd, and they'd probably all roll around. If they didn't roll around and they're just like embedded in each other, yeah, it would be kind of visually upsetting to someone. The wheelbarrow, you're not going to stack wheelbarrows in your level and create some sort of a tower out of them that the player can jump on. It's going to look weird. So think about surfaces first, and think about what you can use as a surface. Those are really, a priority placeholder assets you can construct. The second thing is going to be, what can you get the most out of by putting a lot of them into your level and have it not look visually, disorienting or awkward. So barrels at that point, if you had a bunch of barrels against a wall, as long as there isn't a million of them, not going to be really upsetting to the player. But if you had gas cans and you put, thousands of gas cans just sitting on the floor for some reason, it's going to look odd. It's not, it's not a believable environment. So it's another way you can prioritize what is worthwhile as a placeholder object when you're building these things. A pickaxe, you're not going to build one pickaxe and duplicate it 100 times and put them in one room. You might have them every so often, but it's like a C priority thing at that point. So think about it. If the first thing to think about when you're building stuff from your references, you look at it and go, what can I use as a surface as well as a decorative prop? The second thing, what can I put a lot of down in my level and it not be visually upsetting to someone when they see it? Trying to keep people immersed in the level, immersed in the space that they're playing through, trying to make it feel less like random game objects placed everywhere and more like a believable space. And then you can add stuff afterwards at the end. This piece of concrete right here, great level, great breakup object. If you're thinking about objects that are a method of structure breakup or that sort of thing, just a good example. Okay, so as you complete these objects, you want to turn them into a prefab, because prefabs are instanced instead of duplicates, and it's going to just make your prototype, your test area run faster, and your level eventually will run faster that way. So if you make a wall, and like I was saying earlier, a wall that's like a 4x4 wall or something, and you make a prefab of that, every time you want to increase the length of your room, you can just grab another wall, grab another wall, grab another wall, and you build this kind of like Lego blocks. The one good thing about prefabs as well, this is something that I'll try to cover in the next lecture, is that if you build a very simple version of the silhouette and then you use it everywhere in your level, and then you decide that you want to add something to those objects, add detail to it, add other pieces to it so that it looks more like your theme, you don't have to then go edit all of the hundreds of walls you placed. You can edit that one prefab and make changes to the prefab and then apply it, and it'll apply to all the walls that are in your level already. So by creating the one object that you can then place everywhere and get the structure going, you can then edit that prefab and it'll apply those changes to everything else. So it's one nice way of getting a lot of extra time back while you're working, instead of modifying every little piece and part throughout your toy box, throughout your level. Just being able to apply changes to one prefab and have it apply to everything in your level all at the same time is excellent. So you should have something that the player can move with the graphical. That's the core mechanic that the player's got. So if you have a prop that you want to make dynamic, you can move around, great. Keep in mind that when you're building dynamic props, the player can move them wherever they want. So if you have an object that is big enough that the player can jump on top of it and then get out of bounds of wherever it is that you're trying to build your level to set up your gameplay setup, that sort of thing. Keep in mind try things with the objects you've created that you don't want the player to try, and see if you can escape outside of the testing environment, outside of the level, and get to places that you don't want them to go. If you can, then you can change those objects so that it's don't give them like a bunch of boxes that can move around, because then they can stack them wherever they want and they can escape out of things. But earlier we talked about the ramp for the stairs. You can create custom collision to stop them from jumping outside of the bounds of wherever it is that you're having them complete a gameplay setup. So think about that when you're actually constructing out your spaces. So level mechanics. You're creating two working versions of your level mechanics. Remember, one room for level mechanic 1 room for level mechanic 2. Those level mechanics should validate a core action, and then you should respond with some sort of success event. Now, specifically for the prototype, we're going to reward them with a collectible for completing this level mechanic, for completing this gameplay setup. So in the test area, you're going to have a collectible that can be seen by the player but not interacted with. Remember that the collectible is inside of the Scraps Tools folder. It's just a little cube that you can pick up into your inventory. So beyond the success event, whether or not it's a gate raising or a bridge, getting built, or a floor collapsing or whatever, beyond that, you should see a collectible that you cannot get at this moment, you cannot access. But once you complete this gameplay setup, the player should be allowed to approach this collectible and collect it. But they don't know that there is a collectible if you don't show them where it is at first. You're leading them to and through this gameplay setup. So the collectible should be visible but not accessible. Once they complete this level mechanic, the gameplay setup, the success event plays, whatever it is, and then you can access this collectible. That is one complete test area. So if you are not sure how to get something working for this milestone, we have 3 interactive objects that are already there for you. Remember, you're making 2 level mechanics, so do not pick all 3 and make these, all over the place in your level. The goal is to create some form of teaching or level progression in your level project. So if you're not teaching 2 level mechanics and you're instead just putting random things in your level because you want it to be cool or interesting, the goal is to teach the player as they play through the level. Having more stuff is not always better, but consistent teaching is, good level design. So you have 3 objects. The lever can be pulled forward and reverse by pressing E. The pressure plate, you can stack an object on it, and depending on the settings on the inspector for it, you can require 1 object or 10 objects or whatever that you want to put on top of it. If you require 10 objects on the pressure plate, that is repetitive, and depending on the size of those objects, is really painful to place on top of it. So think about that when you use it. You really shouldn't be checking for a ton of objects on top of it, because it's making the player move things individually over and over and over for way too long. We always want to make sure that the player's not doing, like, you want less than 10 seconds of repetitive action, otherwise it gets repetitive. Finally, the switch panel at the end. The switch panel looks like a pressure plate, but it's different because it's a button, the button that can be pushed in and a button that can be then pushed again to retract. So putting objects on it will push it in, but removing objects will not release the button. So these are more commonly used on like walls or ceilings, and having the player launch something at it to activate it. Or you could have the player like jump on them to turn them on and off. But they're not pressure sensitive. They're on press, it presses, and on press, it releases. So that's the difference between those. All right. Oh, one more thing with those. They use Unity events. There's a Unity events document here, but I also have a ton of videos that show you how to have Unity events talk to animators, to tell sounds to play, to tell animations and visual effects and all sorts of stuff to work. Should not be too confusing. If you're confused by when you first look at them, definitely go to the course resources and pull up one of the videos that talk about the interactive objects and getting them to work with something. It'll be much easier to understand what Unity events are doing. But if you don't want to see a video, you can definitely check out that document right there and walk through setting those up. Player feedback, I mentioned earlier, at least 3 forms, things that count as player feedback using the message system. I did that in the lecture previously. So you can send a message to this message system to say something happened. Tell the player they need to press E by using the interactive objects component. The interactive object component uses Unity events. So if you've made a door open by using an interactive object component, then it's the same thing. Playing a sound when something happens. If they pushed a button, make a pushing button sound. If a door opens, make a door opening sound. Change the material on something when something happens. You can change materials through the animator, or you can store the mesh renderer component and then swap out which material is currently inside of that material variable on it. And you can do that in C#. So if you wanted to have turn on button, cause it to turn green, then store a green material and replace the material in the mesh renderer with your green material when it's on. Same thing for turning off. Turn on a light when something happens, enabling a light, on and off, or also the emissive material. It's a material, so you could store another material as your off material and then swap between on and off. Emit some particles when something happened. Once again, I have some videos that talk about making particles, but I'm not requiring you to make a particle system. So if you want to make some sort of sparkly material, you can either make it or you can go download something. Particles, totally okay. But those are different ways to add player feedback. So your test areas, this is the final part of this section, and then we'll get into the submission. So test areas, in this, you are using your modular placeholders that you've constructed and your level mechanics to set up 2 test rooms or spaces for demonstration of those 2 level mechanics within a gameplay setup. So that's what we're building. Remember, this is not what you turn in. This is just an example of 2 areas. I usually get this question a lot, which is, do they have to be 2 separate areas, or can I connect them together? We're not creating a level. This is not level progression. They shouldn't be connected together. If they are, it's not a problem, but our goal is not to create level progression inside of this prototype. It's to create 2 spaces that you can test these level mechanics out within. So keep that in mind while you're building. This is not your level, not your level. We're building the objects that will be used to construct your level later on. So this is a description of what it would be like when you test your prototype. So you can either close your eyes at this point and listen to me as I read it, and then imagine what your prototype looks like, or just keep that thought in mind as I talk. So when the game starts, you should be able to enter 2 different test areas by walking into them via a door or opening. When you enter the test area, you should be able to identify the theme of the area from the placeholders used to construct it, see a collectible in a non-accessible area, and be forced to complete a gameplay setup using one of your level mechanics, 1 per test area, as a method of verification of a core action. When the gameplay setup is complete and the player knows it is complete via the feedback given to them, a success event should occur and give access to the collectible that the player can now approach and collect into their inventory. The player should be able to exit that test area and enter the other one and repeat the steps above. That's it. That's how the prototype should play through. That is a walkthrough of one room and then telling you to repeat it in the other room. So this milestone can seem confusing if you are expecting to do a bunch of work. You are required to make a very small piece of this. You're making the objects that go into constructing your level, but our goal is to verify that you're actually creating working level mechanics and you actually have the objects that you will use to construct a level later on. So you may want to jump forward and immediately start constructing this amazing, level map that you've created. But we're not going to build that until we have the objects that go into it. Because if your level mechanics don't work at the end of this milestone, we have to cut them. We need to replace them with something else. So now is the time to figure that out. So it says return to FSO to continue this activity. The last part of this, the one thing I wanted to cover before we shut this down, is that submission requirements document. So here, remember, prototype at the very bottom, submission requirements. So this document walks you through the process of submitting your work to Perforce. You may know how to submit to Perforce, but there may be a step that this covers that you need to know about. One of those, there definitely is a step you need to know about. That's what I want to cover. But in here, it walks you through the process of submitting your compiled build and updating your working folder. One of the first steps in here is if you have a project, if you have a compiled build that is currently on the depot, you need to remove it from the depot. That means you need to go to your compiled folder, to wherever your last name, first name, personal build folder is, and you need to mark it for delete and submit it. Remove your build from the depot. Once you've removed your build from the depot, you're creating a new compiled build in Unity directly to that same folder location that your previous build was. So it says created to the same last name, first name folder. When you create this build, you need to make sure that your build settings match these settings specifically. And so as I'm walking through these, each one of these has a little link to another document. So if you don't know how to remove a build from Perforce, you can go to this document and it's going to walk you through, step by step with pictures to get you to the end of this process. So if you're confused about how to remove a build, walk through actually removing a build from Perforce so you can get another one up and ready to go. Then when you go to build it, when you go to make a build, your build settings need to be set up this way. So if you see in this image, it says the scraps menu is the first scene on the build settings. That's scene 0. So scraps menu scene 0. Scraps credits is scene 1. And then outpost, you see here, doesn't have a number at the end and it is disabled. We have to make sure that the outpost is disabled for this milestone. Then you're going to add the toy box afterwards, but specifically it says the scraps toy box should be your initials toy box from the instructions. So you've made a duplicate of this toy box scene. That's where you've been doing your work. That's what should go under where it says 2. It's the fourth scene in this list, but remember 0, 1, disabled, 2. So toy box comes after the outpost, but it's enabled. And then finally, the last scene is there's a dummy scene called level scenes below this scene. That's used for first playable and then in project and portfolio 3. So that's your final scene in the build settings. And that's what they should look like when you make a build for this milestone. If you enable outpost and toy box at the same time, duplicate player characters. If you don't have the toy box there, then it's going to load the outpost. If you put the toy box after level scenes below this scene, it's going to cause you that duplicate player issue still. So think about that when you go into it. Making a build, double check these build settings, make sure yours match. Then you made that build. That build is now in the folder where the original one was removed. After you've created this new compiled Unity build, you're going to submit it to the depot, very specifically submitting it with a change list description that must say submission for prototype. That's if you are getting graded on this submission. So if this is the final submission of this project for the due date, make sure the change list description says submission for prototype. That way your instructor or myself can identify immediately which one you submitted, what date it was submitted on, and treat that as the date that you had submitted the project for the purposes of the late policy and things like that. It says if you type something different into your change list description, you can edit that change list. So you can either go to view submitted change list and then edit the submitted change list, or you can right click on the change list directly and edit submitted change list to change the name of it. Changing the name of it's not going to change the due date. It's just going to make sure that I don't grade the wrong project. Now that you've submitted a compiled Unity build to Perforce, you have to test it to make sure you submitted it properly. This is the step that everyone skips, even though it says do not skip step 4. So in this process of testing your own work, Um, the very specific step is after you submit it to the depot, locate your build in the depot, right click on it, and then select get revision ... not get latest. Get revision ellipses, which is going to give you this pop-up window. So a new window opens, has the location of your compiled build. You're going to select get latest revision, force operation, do not have safe update checked. Only get revisions is grayed out. So if you see a check mark and only get revisions, if this was not grayed out, that would matter. You wouldn't want a check mark in that one, but it's grayed out. It's not appropriate when you're doing get latest. If you were doing specify revision, you would want to uncheck only get revisions for files in the change list. And then finally, remove files from the workspace needs to be checked. So enable force operation, enable remove files, disable safe update, get latest revision, and then hit get revision, and that will force download your compiled build again. So whatever you have on your workspace will go away, and it will download exactly what you just submitted to the depot. And then you're going to test that by showing it in Explorer and running that build. And if that build gives you infinite characters, if that build has the outpost and not the toy box, now you know that it was submitted incorrectly instead of your instructor catching it later. So those are the steps to test your own work. Make sure you do so. If you submit something and it's wrong, remove the build and start again. Go back to the top, remove your build, and then add a new one, so on and so forth, and then test it again. Finally, at the very bottom, step 5, update your project folder on Perforce. In here is just a basic overview of backing up your work to the depot. So it talks about ignore lists. It has topics for how you're updating your project. So are you marking things for add or check out or delete? Why would you use revert unchanged files? What do we type for a change list description? Repair if you want, if you've gone a week without submitting updates and you're not sure what you've changed, what can you do to, get Perforce to find out what you have changed? You can go in and look at how reconcile is described and walk through those steps. And then finally, repair and protection. Someone changed my files. What can I do? Resolve and lock explained. This document should walk you through the process of getting your work up on the depot so that you have a backup ready to go for this milestone. So at the very bottom, it says, once you've completed the steps above, copy the location of your build folder on Perforce in the depot and submit that as your response on FSO. So if you do not want to have a grade for this, do not submit the prototype activity. If you want a grade for this, make sure that it is up on Perforce. It is named submission for prototype. You have a working folder backup, and you've tested it. And then submit your response on FSO. This activity can be submitted late. So when you get done with all of this, the completion section will be open to you even when it's late. So you should submit your completion here. Do not submit completion in feedback. Feedback is like the comment sections on Facebook, except for it's between you and your instructors. That doesn't mark the activity as being submitted by you. So make sure you submit completion to notify your instructors that you're done with this activity so they can grade it. So that is everything for prototype for week 2. So we're all good here. I'm going to go ahead and wrap this up. And then for those of you that are here with me, we can discuss about whatever questions you might have. So let's go ahead and stop the recording. Thanks everyone for watching this, and good luck this week.